Welcome to the Geodesic Dome tutorial video. Here you will find how to construct your own geodesic dome using parts available online and locally. You can create a beautiful space with just a couple of friends and some basic tools. You can create a super strong structure that resists earthquakes, heavy weather, is beautiful, and feels wonderful to be inside. The full spectrum of energetic waves are available inside a dome structure, unlike a typical square structure, which blocks energy. So don't be square, think outside of the box. The first step in building a dome is deciding what size to build and getting the right dimensions. There are several sites online, but domerama.com is our favorite. Step 1 is to get dimensions of the struts by putting in the diameter. And then once you calculate that, you'll get the height and the area and the perimeter. Once you scroll down, you will see the feet, square footage, and the exact strut sizes that we will have to cut as step 1. There's 2 on this case, and I'll count for the holes, so you have to add a little bit extra. If you continue down, you'll see exactly how much hardware you'll need and the hubs. In this case, we won't have any hubs. We will just be drilling holes in the pipes. And there are different materials you can use, and these prices may vary based on the time and your location. But most importantly is the bottom diagram, which we recommend printing. You can see exactly where each strut goes, and that's first step, is to cut these struts. This is where we're going to do it. Just a simple tent, carport tent. We have a press and a grinder and vices and a drill press, and you can see we've already cut our struts here and flattened them. I'm going to show you the saw we used to cut them. It's just a simple saw that has a blade that doesn't leave frayed edges, which is very important. We never had to use a grinder, thankfully. The links to this saw and all parts are on futureofthefree.com. On all steps, but especially the cutting of the struts, face protection is very, very important. After cutting the struts, it's very important to flatten the edges in a level way so that both ends are on the same plane. You want to make sure that everything is exactly where you want it by using the guides, and we use a hydraulic press here that is just a Harbor Freight press fitted with a pneumatic jack. Those black plates there came with the press, and the middle portion there is just a sandpaper block, soft sandpaper block, and it smushes just right, allows enough space so that the strut pipe can go in. Watching it smush here is probably one of the most satisfying parts of this process. And just take your time, go slow. That's probably the best advice I can give on this whole process. So once it's smashed all the way down, you can see, we'll release it using the little release tool, and it will come out, and we did everything right and lined it up straight. It should be nice and flat. Taking it out, there it is. Looks great. And we're gonna go ahead and put them aside and stack them up and get ready for the next step. I'm gonna reiterate, safety, safety, safety. Put your goggles and your face mask. And let's get back to the shop. Second step is to drill the holes. There we go, setting it up. You can see that we had lined it up, and I created a little system here where I have the vices, and I have a little wooden mold there that I created. You can see with the green tape, and that is so that I have the exact area where I need to drill the hole. If you remember, we added a little bit extra area at the edge of each strut to make sure that the hole measures the exact measurement we need from hole to hole. We add oil, very, very important. You'll get a bunch of smoke, and you'll actually see this was one of the first holes that I drilled, and you'll see some smoke forming that, not yet, but I got enough oil there, but I got a little bit, see that little smoke there? I got a little bit overexcited and didn't add enough oil, especially on this next drill. Um, as I went on, that wood guide that I have there, you see that I have clamped. Ooh, there goes the smoke again. That's what you don't want to do. But what I did do right was that wooden guide. It really saved me a bunch of time. You can see I just grooved a little area right there. You see how I grooved a section there so that it fit. Next step is to get the right angle, and we'll go back to the Domarama site, and you'll notice that right where the strut section is, there's the angles for each one, and we use an old-fashioned protractor to set the exact bend that we will need. We put it on the vise, and in this case I used the roof so I knew where to stop bending. That's an easy way to make it a quick process, and then once you have it set up, you'll get the right angle every time. And you can always also check it and make sure on each one that you have the right setting there. It is forgiving. Once you put the dome together, it'll bend a little more if you don't have it exact. So, but it makes it a lot easier if you have it more or less. There it goes. So, yeah, great. Next step is get your alien friends to come do a little crop circle, and you can get your family and friends to help you put it together. It goes together quite easily. You notice the bottom portions here with the cross beams. Those are not part of the dome diagram, and I'm going to show you. We use the same website, the Domarama website. In this case, it was a 12-footer. So we got the dimensions of our A and B struts, and you can see where they're located. So the bottoms are B. It is 3.708. So we're going to get that B strut, and we go to the Pythagorean equation on Google, and it'll give you this nifty little calculator. Here it just happens to be labeled B as well by coincidence. So we're going to put the 3.708 in the B section, and the A section will be our vertical strut. We'll put that dimension as well. But we chose 3 feet because that's how tall we wanted it. And then we get the actual C, which is the diagonal. And that's what we use as a calculation to cut that C, that cross beam there. You see that worked quite well. Very sturdy. We continued to put it together after we got the bottom portion built, and the dome itself on the top came together quite nicely. This is not something that is super difficult. Myself and my 80-year-old father were able to do it, and I'm not a construction guy or very mechanically inclined, so I believe anybody can build these. It worked out really nicely. You just have to have some struts hang, as you can see, and then you arrange them as you go. They'll bend a little bit into place, so it's very forgiving. The building of the dome was a lot of fun. After a lot of cutting and drilling and measuring, this is by far the most rewarding part of the process, is once you get the dome together. You can see it coming together there, the top vertices. The very last piece, sometimes you will have to adjust the dome a little bit to make the very last piece fit, but as you can see, it turned out quite nice. As you construct the dome, you begin to realize why it has so much strength. Every member is associated and connected and supports the whole. And this is very representative of how nature works. Notable features are the sound that you get in the middle of the dome from the shape, the confidence you have that it's not going to collapse on you. It's not like a typical square structure that is essentially on stilts. It's obvious how strong it is as you put it together, and hope you all have fun doing it. The next step is cutting the outer panels. First, we use a template that we create using a guide so that the saw creates a straight line. This is done using a guide that we create with just cardboard panel. First, you make a template using paper and the right measurements. Cut the sample and make sure it fits. In this case, it fit quite nicely. So once you know you got the right size, you can create the actual pattern out of the same cardboard panel and lay it out on the plywood. Clamp it so that it stays in place. And once you have the lines drawn, you can use your guide that we created to make sure you cut a straight line. Once cut, you can place them on the dome and make sure you have proper spacing for rubber gaskets that we'll put in a later step. Next, we'll add holes on our patterns for the magnets. We space them out so that there's enough force to hold and screw them in to each panel, and then we can test that they hold properly. And it worked out quite well. Next was the windows. We used plexiglass and got a fine blade and made the proper size that we wanted on the panels. And once in, we used silicone and used wood trimming to make a nice frame, and used a miter box to angle it correctly. Next, we put them together with small finish nails, added some more silicone on the inside, and it turned out quite nice. Next, we created a simple floor using paver stones that were leveled and placed evenly, bricks at the front for the doorway. We could have done something much more elaborate, but we chose tongue and groove boarding with our guide to cut straight lines again, a moisture barrier of plastic, and it came out quite nice. We just placed it, and it has lasted the test of time. We are now ready for the next step, putting the panels. For the door, we drilled carriage bolts into the frame of the struts and added 2x2 redwood as a frame to support the door, and also we used pipe clamps to also secure the inside panels for security. This is what it looks like at the very end. You can see we used brackets, which we bent slightly for the curve of the door, along with 2x4s as the frame, also redwood. And you can see the carriage bolts from the outside that support the brackets on the inside and the frame, and it worked quite nicely. And we're now ready for our next step. With the floor in and the door established, we're now ready for the final stage, which is to put the panels on our frame. It started looking quite nice as we started to put our panels, and the structure itself supported everything very easily. The cross braces at the bottom created a nice foundation and gave us more height, as a 12-foot dome is only about 6 feet tall. It really started to take shape. This is the 12-footer. On larger domes, you will need to cut 4x8s into 2 sections instead of the 1 section we used here with the 12-footer. And it seems you can go up to about 36 feet using 4x8 plywood sheets. The reason you have to cut the sheets in 2 is that the 2V domes have larger triangles. You could do a 3V or 4V dome, but you would need 165 panels on a 3V instead of the 65, which means a lot more cuts. This also applies to the insulation panels, which we cut into triangles and used aluminum duct tape to seal the edges. The plexiglass also comes in 4x8 panels. The final step is to incorporate rubber seals to cover the air gaps, and you can find many different solutions for this. So here we are at the final fun stage of putting all the panels on. There's great satisfaction in the magnetic panels. Once you put them in or take them off, it's very easy. This can be a portable solution where you put rubber gaskets in between and cover it, or permanent, and you can put brackets inside so that they can't be popped off, which we did here. And here's a full time lapse of the entire process, all the panels being installed. It took approximately 20 minutes, taking my time, and you can see it can be done with one person. Once this is done, again, you can put silicone and rubber seals. There's different kinds of seals for doors and for windows, and you can pick the right color you want as long as it's an outdoor seal that is weather resistant. And then the pipe clamps on the inside as well as the door lock make it pretty secure. In this case, we didn't put the silicone. We wanted to be able to take it apart and make it a portable dome. So we did put clear plastic tarp over it so that no rain comes through. So you have your choice, and again, you can make this into a 24, 36, or even larger if you go with the 3V dome. We also sealed the wood with a nanoparticle cement seal for weather resistance, and then stained it with wood stain, and we chose green and yellow and brown accents. And this is a final product. We actually ended up putting music gear, and it's quite beautiful acoustics. We did bubble wrap in the inside ultimately, as you can see, just bubble wrap sheets, and we just put the tarp on, and it's now a great little studio. There you go. We put some nice neon lights in it, and this is the final with all the music gear, and again, the acoustics inside are unparalleled. Beautiful sound right in the middle. This was a fun family project that only took a couple days to complete once everything was cut. The next dome, we decided to get the tribe involved, and it was a great help. Same setup, base rock and cinder blocks. We used 4x6 boards as the foundation platform, and some great help from some great people. As you can see, it all came together in essentially the same way, just raised up a bit more. We used some scaffolding so that we can get to the very top. This was the 24-foot 2V dome. Turned out really, really sturdy. It has been up for about 3 years and has stood the test of time. The final joint is always the most rewarding moment, and this is it. The final bolt on the top. And yeah, this was quite a project, and it came out beautifully. It's a large area, about 423 square feet or so, and it's just magnificent to be inside. You just feel a different sensation than you do in a square structure. We used clear vinyl for the windows, secured with magnets, and chose a semi-transparent tarp, which allows it to be bright so that it can be used for an indoor garden, a recreation room, a playroom, or a place just to hang out and meditate. Very nice feeling inside. Adding wood panels, like we did on the 12-foot dome, would make this an ideal living structure that can be easily built. After finishing the structure, it was time to celebrate with food, family, and friends. It was a nice closure to a great project. Coming together in community and cooperating has been the premise of this project. You can find the part list and tool list on futureofthefree.com and build your own round structure and find all the benefits of creating something that is sustainable, super strong, and feels great to the senses. The energy of nature is mirrored inside the structure of a geodesic dome. I hope you can experience this in your life. By learning from the movement and the mathematics of nature, we can learn to live on Earth without some of the issues that we currently face. With a bit of thought, we can reflect the cooperation and the intelligence, the cleverness, and the beauty that is all around us, and create communities and ways of living that are in harmony